Alright, welcome to the Unit 9 test review number 4. Now, in this case, we have two logarithms with the same base that are being added. And so the question becomes, well, whenever I'm adding these two logarithms, what can I do with the quantities on the inside? And hopefully you remember that the answer is you can multiply. Okay, so what in the world would that look like? Well, that would really look like this. It would look like the log base 2 of x minus 2 times x is equal to 3. And this is actually going to be a rather interesting example that I really want y'all to be able to see. So this is telling us, let's get the right grin here, that we really have the log base 2 of, I know that x times x is x squared, it's a quadratic, and negative 2 times x is negative 2x. Okay, and that's of course all in parentheses. Now at this point, how in the world do you get rid of a logarithm? Well, you get rid of a logarithm by raising it to the power of its base. So for instance, if this is a base 2, I put everything into the power of 2. All right, and what I do to the left, of course, I do to the right. Okay, well this is going to greatly simplify our problem because now our 2 and our log base 2 cancel, and we're now left with this. X squared minus 2x is equal to, I just want to show you that 2 to the power of 3 is, of course, 8. Now in this case, sorry about that. My wife is bringing me coffee. Okay, so anyways, at this point, we now have x squared minus 2x equals 8. And notice since it's a quadratic, we simply want to set it equal to 0. Okay? So we now have this. We have x squared minus 2x minus 8 is equal to 0. It is up for you to factor this, figure out what x is, and write your final answer. Remember, there'll be two solutions. Alright, let's go on to problem number 14. Okay, 14 says find the inverse of the function below. Well, we know that we can just switch our f of x to y, but then we know that, the idea of an inverse function is to switch x and y. So I've seen some students get really comfortable just switching these right off the bat, and truthfully, that's where I'm at myself. If I don't have to rewrite the f of x as y, that's okay. Okay, so we've switched our x and our y, and we now have this. Now from here, of course, we just want to do our easy subtraction. Let's get rid of our addition. And so we have x minus 4 is equal to 7 log base 3 of y plus 5. Now from here, well, how do you get rid of that 7? Well, it's kind of nice to be able to divide it. We'll divide both sides by 7. And at this point, we have our x minus 4 over 7 is equal to log base 3 of y plus 5. Now from here, how in the world do you get rid of a log base 3? Well, same thing that we just did. We know that we want to raise it up into the base 3 and base 3. And at this point, those two things cancel, and we should now have this. Let's rewrite over here. We have 3 to the x minus 4 over 7. You really want to emphasize that that is small and in the exponent. And leftovers are y plus 5. And since we're so close to finishing, I think I see a lot of students make a mistake here. You subtract both sides by 5, and you simply write this. Y is f inverse of x is equal to 3x minus 4 over 7 minus 5. And you really want to emphasize that your 3 and your 5 are the exact same size. Alright, I hope this helps. Let's go into problem 15. Okay, problem 15. Now, I'm not going to lie, this is relatively easy. We've been doing a lot of this since the actual, maybe the 4th or 5th lesson of the year. So the only thing I'll show you, just as a quick refresher, is what does it look like to distribute one of these terms, okay? And I'll give you a little hint for the second part. Okay, well, we know that right here we have an m cubed times everything inside this parentheses. So when we do this, we're really saying, hey, we have 1 times 5, which is 5, and m to the 3 times m to the 3 is really m to the 6. You just add your exponents. So m to the 3 times negative 4m, so 1 times negative 4 is negative 4, and m to the 3 times m to the 1 is really m to the 3 plus 1, which is 4, and m cubed times 8 is obviously 8m cubed. Now, I am not going to distribute this for you. You should be able to distribute this on your own. The one thing that I'll write is that, yes, you do have to do the negative 3m squared times m to the 4 and the negative 3m squared times negative 7m. And I'll let you all finish it out from there. All right, we've got one more example. Let's move on to problem 16. Okay, 16 says, what is the exponential form of the equation the natural log of 6x plus 12 is equal to 8? Now, truthfully, I'm actually not a fan of problems like this, but the exponential form is just telling us to basically do one step. So here's my question here. How in the world do you get rid of a natural log? Well, remember, the natural log is really like saying base e of anything, so let's just say base e of x is equal to the natural log of x. That means that in order to get this, or to get rid of it, we have to raise everything into the exponent of e. Now when I do that, what happens is the e and the natural log cancel, and I'm left with this. 6x plus 12 is equal to e to the power of 8. And this is simply the exponential form. They are not asking you to solve for x. They just want the exponential form. Make your one move, and you're done. All right, I hope this was helpful, and let's move on to our fifth and final video.